groups. Okay, these are the functional groups. Chromophore, these are the unsaturated functional groups. Unsaturated means that functional groups contains the double bond. So chromophores are the unsaturated functional groups. Okay, basic. See, double bond is there, so obviously it will absorb the UV radiation, because UV radiation, in the UV radiation, actually for we study the unsaturated compounds in the UV spectroscopy. Okay, so chromophores are the unsaturated functional groups. So which groups? There are the NO2, then N2, then carbon double bond carbon, then carbon. So these are the unsaturated functional groups. In these groups contain the double bond. So they can absorb the UV radiation. So these are the chromophores, okay, unsaturated functional groups. And the other word, other term is there, that is auxochrome. So the auxochrome, uh, these are the any group, okay, which itself does not absorb the UV radiation. So these groups include, actually auxochrome includes the groups such as OH, that is hydroxy group, then NH2, NR2, SH. So you can see here, so OH, so these groups contains the lone pair of electrons. They not contain the double bond, but they contain the lone pair of electrons. So they not contain the double bond, so they itself not absorb the UV radiation, but they contains the double bond, or that double bond, it contains the lone pair of electrons. So they contain the lone pair of electrons. So their presence in the molecule brings about the shift of absorption band to the longer wavelength. Why? Because the lone pairs which are present on that group, okay, they will take part in the resonance, and there is a conjugation. They take part in the conjugation. So there is an extended conjugation in the molecule due to the presence of auxochrome. And that's why there is a shift of the absorption band to the longer wavelength. And then there is an increase in the wavelength, like it will shift to the longer wavelength. So the difference between chromophore and the auxochrome. Chromophore, these are the unsaturated functional groups. Okay, so they can absorb the UV radiation. In that, the groups include NO2, N2, then carbonyl group, C double bond, C carbon carbon double bond. Okay, and auxochromes, these are the any groups which does not absorb the UV radiation by itself. So these groups contains the hydroxy, NH2, OR, NHR, NR2, SH. So these groups, on these groups there is a lone pairs are available. Now there is a chromophore auxochrome interaction due to the presence of auxochrome. So we have studied this. Now there is a visible spectroscopy we have studied. Okay, visible spectroscopy. So that for the visible spectroscopy, the range is 400 to 800 nanometer. So it's normally its principle is same as that of UV spectroscopy. So there is a development of color. So for that we studied the examples like conjugated polines. So see, the beta carotene is the example where there are 11 conjugated double bonds. 11 conjugated double bonds are there, and It shows this compound shows the strong band at 452 nanometer and the second band at 478 nanometer. And see, it is comes in the visible region, that range, wavelength range, 452 and the 478. So that comes in the above 400 because 400 to 800, it is the visible region. So this wavelength range comes in that region. So it is orange color. Okay, it is orange color compounds. Now in that second, we studied the aromatic compounds. So aromatic compounds, we have seen these three. Benzene, normally it is the benzene, it contains the pi bond. So they require the energy to carry the pi to pi star transition. So that energy is pi to pi star energy is actually high energy. That for the pi to pi star transition in the benzene requires the higher energy. So that energy absorbs in the it absorbs in the UV region. Then if we take the nitrobenzene, so on that NO2 group, so that is the chromophore attached to NO2 is a chromophore. So that is attached to the benzene. The benzene it also contains the double bond, so it is also a chromophore. So additional NO2 group, okay, it is added to that. So there is a little conjugation extent. There is an extension of conjugation is there, little, okay. So that will shift the increase in the wavelength. So there is a increase in the wavelength. So the energy obviously it becomes lower. Okay? It becomes less than the benzene because energy is inversely proportional to wavelength. So nitrobenzene, so basically in the nitrobenzene, it is a pale yellow color. Then further, uh, if it the NH2 group is added on that group, okay, so it becomes para-nitroaniline. So in that we are adding NH2, it is a auxochrome. So it contains the lone pair of electrons. So the lone pairs will take part in the conjugation. You can see. So there is a further extension of conjugation is there, and further it will increase. That is the bathochromic shift is there. So it will further shift the bond towards the longer wavelength. So its wavelength will increase further. So obviously the wavelength is increasing, so energy become less than the benzene and the nitrobenzene. Okay, energy required that will become less than these two compounds. So that energy will fall in the visible region. So that's why the para-nitroaniline, it is a deep yellow color. Then there are di molecules are there. The di molecules. So the di molecules in that, the first one, it is a leucobase. It is a di molecule. So it is a leucobase which is colorless. So it absorbs in the UV region. It absorbs in the, it is colorless because it absorbs in the UV region. Then see, we treated it with the acid HCl. We treated it with the HCl. Then its conjugation is extended, and that absorption will shift to the into the visible region. So that's why after treatment with the acid, okay, after the treatment with the acid, that is the HCl used, so its conjugation increases. So it will shift, the band will shift towards the visible region. So see, after the treatment of acid, it becomes crystal violet color. It color becomes crystal violet. Then again, in stronger acid solution, in the stronger acid solution, it exists as a See, it is exist as a green. Further, that is the it exists as the third one. Okay, that is it will appear green. So that changes to the cream color. Why? Because increase in the resonance. There is a further increase in the resonance. Then again, um, in concentrated acid solution, okay, in concentrated acid solution, that color turns yellow due to the formation of the that last ion. Okay, see the difference in the structure. There is a conjugation increasing. There is a resonance increasing the resonance. So its color also gets changed. Color also changed. Okay. So the visible. So this is the example of dye molecule. So first the molecule it is a colorless, see the leucobase. So after the treatment with the acid, see the changes. It forms the that is the violet color. It becomes violet color. There is an ion formation. Then after in the stronger acid solution, it exists as a in this way, like third structure you can see. So its color becomes green. And further, again in the concentrated acid solution, its color becomes yellow. It forms that ion. Okay, there is a further change in the molecule. Okay, there is an increase in the resonance. See, in the stronger case, in which the third one, in which the green color, it appears the green color. So in that green color is due to the increase in the resonance. And see, in the last one, in that the color turns yellow. Okay, because there is a further change in its structure, change in the structure. So in the last, see the color becomes that is yellow. Okay. So in this, the resonance is decreased, and therefore the absorption shifts towards the shorter wavelength. So the first it is colorless, then it becomes violet color. Okay. And then it becomes green. So in that case, the resonance is increased. That's why we got that color. Okay. Violet color, it is a dark color like green also. And then at the end, okay, resonance is decreased. Absorption shift towards the shorter wavelength. So its color change, that is the yellow color. So the visible spectroscopy has the many applications. The colorimetry. Colorimetry is based on the visible spectroscopy, in which the fixed wavelength is obtained in filters. And in that case, the color intensity, okay, is proportional to the concentration of the substance in the solution. So the colorimetry, it is used for the quantitative estimation. Now see the quantitative and there is a qualitative estimation. So qualitative means in that we only calculate the we not calculate the quantity, but in the quantitative estimation we can calculate the quantity. That is the difference. Quality, there are the qualitative estimation. In that only we can check that presence or absence of particular metal or whatever the ion. Okay, but in the quantitative we can calculate its amount. Okay, we can calculate the quantity. So many metal ions form the colored complexes with the organic reagents. And see the visible spectroscopy,